I'm okay. So now this is the architecture for the Golden Gate. Okay, and like you can see on the source side, they are extracts. Okay, so the manager to manage all this, manage this show, and manager on the both the sides, on the source and the target side. And we have on the target side, you can see on the other side of the network, you can see a collector process, to replicate process. Okay, now let's go through this all the things, and then we can understand this diagram better way. Okay, so now what is manager? Manager is running on both the sides, on the source and the target side, and it is used to managing all this stuff. Okay, it can be used, can be seen as a manager of the cluster, you can say. Like we have cluster like in Oracle rack or something. Yeah, so in this way what it does is, as primary task are your managing of your trail files, managing all the report files, all the log files, report files, purging these files when they are not required, or when they are done, restarting of all the processes. So if any of the process crashes, it is his manager responsible to restart the process. Okay, so it restarts all the process which any of the process crashes. Fine. So we'll study what is report files and what are trail files as well in future slides. Fine. And next is the extract. Extract is which extracts the data from the source, right? It extracts the data from the source. It is a process which reads your redo log files. Okay, it reads your redo log files and puts the data into a file which is known as a trail file. Okay, it is so it puts the data into your trail files, and it reads from the redo log files and puts them into a trail files. It can also be used for initial load. Initial load means it initial load is in the beginning of your replication. You first need to do an initial loading, and then you start your replication. So either you use golden gate also supports initial load, or you can use other mechanisms, Oracle as well, like export and import, rman, such things if you can use, depending on your databases you are using, or depending on the operating system you're using, because Armin will also not support all the operating systems, right? So cross platforms, and depending on the operating system you're using and depending on the database you are using. But if things are okay and you don't have a choice, then you can go with the Golden Gate as well. Okay, so if your own database can support such features of initial load, then you can go ahead with it. And if it's not good, then you can go with the initial load of Golden Gate as well. So initial load it will support, but the issue with the initial load of the Golden Gate is it will not support, it will not replicate the structure of the tables. Somehow you need to use your own tools to copy the structures of the table. It can do an initial load of your only of the data. Okay, so you first need to build the same structure in the target. You have to build all the tables, views, extra everything on the target. Then you can use Golden Gate tool to do an initial load. So in case of initial load as well, extract process are used. Extract process do the same thing in the initial load as well. It just picks the data, not from the log files, now from actually from the database, and transfer the data. So its main task is to pick the data. Okay, pick the data from the database or from the log files, and writes them onto the either only trail files. If they are trail files, we have configured the trail file on the source. If we have not configured the trail file on the source, then sends the data to the target as well. Okay. Now next major process is replicate. Okay. Now replicated, it reads from the trail files. Practically it reads from the trail files if it is configured. Okay, just until you trail files are optional. Okay, trail files are optional. I will tell you benefit why we should use trail files, why should not go without trail files. Okay, so trail files are optional. So it will read the data from your trail files and converts them into SQL commands, and then fires them on the target, right? That is replicate. Now what does the collector does? Now collector is a background process which is runs on the target system, right? It's a background process which runs on the target system, and it's started automatically by the manager. Okay, so it's a dynamic process. You need not to configure the collector. First of all, you need not to configure the collector, and as a maybe user doesn't know, who doesn't know, you will never come to know that collector process is running. Okay, it accepts the data from the extract process and writes them into the trail file. Okay, accepts the data from the extract, writes them into the trail file on the target. Now replicate job is just to read it and convert them into SQL commands. Now collector is not doing anything. The replicate will never write the data to the trail file. It will just read it from the trail files and writes them into the target and fires them on the target. Okay, so it receives the data and writes them onto trail files. Now comes the trail files. Okay, we'll understand this once more, I think. Okay, we'll understand with the diagram now. I think we all get the idea that what all these processes are, and then you understand. Then you can now you can match it with the diagram. Okay, then I think we can then it can be more clearer. Okay, so now trail files is the series of the files which is written in the canonical format, which is temporarily storing the data, which is read by the extract. It can be written by the extract process. Okay, once is it can be written by extract process if it is available in the source system. If it is available in the target system, it will be written by the collector process, right? So it will be written by the collector process. So depending on the configuration you choose, so it can be exist on source as well as on the target, and in case of initial load, it might be not be used. Okay, so in case of initial load, it may or may not be used. Okay, so if it is exist on the local system, on the source system, it is known as the extract trail files. If it exists on the remote system or on the target system, it is known as the remote trail files. Okay, now I think we talked a lot, so let's go back to the diagram before coming to the next component. Okay, now you can see over here, let's talk for the initial load. Initial load, we are reading the data from the database, fires them on the sends data to the replicate process. Okay, sends them replicate fires them on the target database. So there is no trail file initial load, it directly sends. Now in case of chain synchronization, when we are reading from the redo log files, extract is reading from your redo log files, sending the data. Okay, now there is a collector process in between. Now collector process, now there is no source trail files, there is no trail file on the source system in this scenario. It puts the data to the collector. Now collector is a dynamic process started by the manager. Okay, okay, it will write to the trail file. So now what all will be contained in the extract parameter file? In the extract configuration, what all will contain? It will contain the database information from where it has to read. Okay, the database username, password. Okay, which has the access to the which has a good access so that it can read your log files. Good enough access. Okay, now second information should contain the target address, the target machine name or maybe IP, right? So it can contain that, and it will send the data to this process, to the collector process. Now this process, because it now contains the machine name or the IP address, or maybe it also contain the manager port number. Okay, because manager is managing the show, so it will contain the manager port number and the machine IP address. So it will send the data to the target with the help of that information. So manager will make sure that when it sends the data, it starts the collector process. Okay, so it will let this communication happen between extract and collector. So extract will send the data to the collector. Collector will put that into a trail file over here. Okay, so now in case of chain synchronization, this trail file is mandatory on the target system. This is mandatory. Now replicate will read this trail file, converts them into SQL commands and fires them on the target. Right. Now you can see over here these optional components. You can see this is a trail file on the source system, okay, which is optional. So what will happen if we configure this trail file on the source system? Now extract will not communicate to the target. Extract will not doesn't have a information of the target. Extract will have a information to where to put the trail files on the source. The address of the trail files of the source. It will put that trail file into that location. Okay, it will put that trail file into that location, which has the inform which is already configured in its process. Now there is one additional process which I need to configure over here, which is known as the data pump. Okay, this is also known as a secondary extract process. Okay, because it is also extracting, it is also reading from a trail file only. Now this process will now read from this trail file and sends to the target. Now this process will contain the manager port number and the IP address of the target. Okay, now this will not contain this. This is contained in this pump process, data pump process. Don't confuse it with your Oracle data pump, Oracle database data pump. That is different. The name are same, but it's no relation. Okay. So now this will contain. So here in the target things remains the same. Okay. Now comes the point. Why should I need to configure this? Why need to put more, like more process, more files? So main task, why we are putting it, this is called optional, but for critical systems, for where the application is very important, we should put it. For the like let's say a real streamed application, when we want a real data, then we should do it. There is no option actually. It is not optional actually. Just assume the network is dropped. So what will happen in this scenario? Will extract the data. It sees that the network is down. It will not able to send the data. So there is no way it can store the data. It will crash. Eventually it will crash. So maybe it's down for six hours or 10 hours or maybe one day. Okay. No, the redo log files will keep on moving ahead. It might reach to the level that it becomes archive files. Okay, it is holding a pointer from where it has to read, but eventually it is like sitting idle. So when the network is up, now it again start reading. Now the redo log files of sequence number and the RB address reaches the archive. Will go ahead and reach archive. So one thing is archive might be purged, one issue. Second issue is anyways it is would be slow. Okay, archives are generally not put on the faster disk. Okay, so second is it will be slow. So it'll first again will pile up the data for one day, and then it is replicating, but the lag would be more. Now second scenario is network. I configure it. Okay, what will happen? It will keep on extracting the data and pile upping on the trail files. Right, it's piling up the trail files. Even it is not a data pump is not able to communicate. Network is down, but at least I am getting the data from Oracle perspective, because generally some organizations have a different database admin and GoldenGate as admin. Now you don't know the scenario that it is how purging is done in the archive files and how long it's purged. You need to communicate to the DBA that yeah, this is maybe I need the archive of last 5 days or one day, something like this, right? In this scenario, in the SQL Server as well, I think there is something that the arc logs goes old. There is no such log switches happen in the SQL Server, which but I know. But it also there's a purging kind of scenario or compressing kind of scenario for the old logs. Okay, so to avoid all the scenarios, we can configure it, right? So at least we get the data from the database, and when network is up, we can just start sending it. So it will move faster, right? It will move faster, because we already got the data. Now we are not dependent on the database now, so we are sending it. Moreover, now the burden on the extract is also less, so it will move faster. You just need to read it and put them into the local system, need not to work on the network side. Okay, so we have distributed the work as well, so there is no harm in configuring one more process, right? So we generally configure it, so there is no option that we don't configure it actually. Only just for the testing purpose we can skip it, otherwise we configure it. So data pump. So data pump are the secondary extract mechanism which exist in the which is in the source system, source configuration. This is an optional system. I think we already talked about it. Optional system, and if data pump is not used, extract sends the data via the TCP IP to the remote trail on the target. To send the data to the remote trail file to the target if this is not. If it is configured, then primary extract will write to the local trail, and then this trail file is read by the pump and sent over the data to the uh, target. So in the absence of data pump, the data that the extract resides in memory alone, and there is no storage of this data anywhere on the source system. So there is no storage of the data if the data pump is not there. So in case of network failures, there would be cases where a primary extract process can abort. So if network is not there, primary extract will definitely crash because it will try to communicate to the target, it will give the error, it will crash. So GoldenGate processes crashes at every error. Okay, if there is any error, GoldenGate process will crash. Okay, right. So now checkpoints. Now checkpoints are very important component also. It's like a kind of a pointer of a read and write position. So if any process is crashing, how it will came to know from where it has to read. So it's keep a pointer from where it has to read and write. Okay, so these are the read and write positions, fine, for your database. So checkpoint stores the current read and write position of process of the disk for the recovery purpose. Okay. Checkpoint ensure the database changes marked for synchronization are extracted by extract and replicated by the replicate. Fine. So if any process crashes, these checkpoints are maintained in a file known as the checkpoint files. Okay. It keeps a position from where it has to read. Whenever it crashes, it knows from where it has to read. So for the synchronization of maintaining the data integrity, it is very necessary. Okay, and it'll prevent any kind of redundant processing. So it also there's a checkpoint table as well. We can also configure a checkpoint table in the target system for the replicate. So replicate put the its checkpoint in two ways, one in file and one in a table. Okay, and we'll keep on syncing these checkpoints. Okay, so just extracts creates checkpoint for its position in the redo log files, and replicates create checkpoint for its position in the trail file. Okay, so replicate puts a position in the trail file from where it has to read. Extract puts a position in the redo log files from where it has to read. Okay, so these checkpoints keep on incrementing. When the read is done, it's keep on incrementing. Now data sources are the data source, like the database is known as a data source in GoldenGate. This is a terminology we give in GoldenGate. Data source are the redo log files actually. So data source, if you heard about term data source, that means your redo log files of Oracle redo log or transaction log files or SQL Server. So I don't know about the other databases at all. So I can talk a bit about Oracle and SQL Server only. Okay, so now groups. Now each process we call as a process, but in GoldenGate we call them as a group. Okay, so your extract groups, replicate groups, pump groups. So there can be multiple extract. Maybe I put 4 extracts in my database, so that like I am 4 schemas I need to replicate. So I put one extract group for each schema. Okay, and one replicate for each schema. So I will say them: 4 extract groups I have, 4 pump groups I have, and 4 replicate groups I have in my GoldenGate configuration. So we call them as groups, not as process. Okay. So everything is known as the group. Your trail, your checkpoint table, and everything, everything which is used is known as a group. Okay. Now GGSCI is the shell in which we'll type all commands, will create parameter files, which will configure the GoldenGate. This is known as, the full form is GoldenGate Software Command Interface. Okay, so it's a complete range of commands to configure your GoldenGate control, monitor your GoldenGate, or which your commands can be typed or run through a script. Okay, in GGSCI, we'll work on GGSCI only. I told you that in this training will not work on the graphical interface. You'll work only on the GGSCI. Mm. So your parameter file um, is the file which is the configuration file of your each group. Okay, you will create a parameter file for each group, for each extract, pump, and replicate. Okay, so there are two types of parameter files. One is a global parameter file. Okay, global parameter file is a file which is executed at the time you log in into GoldenGate. You know the profile file in Unix, and also in Windows as well. There can be such files created that just executes when you log in into Unix shell. So same way, when you log into GoldenGate, you can create one global parameter file. It's an optional. You want to create, like you want to log into the database immediately when you log into the data. So you have already know which database you need to log in. So you just put a file that can log in into database just when this is done, when this is created, right? When you just log into the GoldenGate, that file need to be executed, like logging to database, setting some parameters for report files or error log files. So the basic configuration you want to set, then you can put into the global parameter file and it will execute once you log into your data in your GoldenGate. Other files are known as the runtime parameter files, which is files for all your managers, for extract, replicate, pump. So for all this kind of stuff, you have a runtime parameter file, which will store all the configurations. Now there are two things which you can do with GoldenGate. One is initial load, and one is change synchronization. Okay, yeah. So initial load is, I told you, that just picking the data from the database and sends to the target, right? Change synchronization is you're picking from your redo log files, right? So this is the initial load takes a copy of your entire source data sets, transform if it is necessary, and applies on the target tables. So the movement of transaction data begins from a synchronized state, right? And change the data capture is data capture from your log files. So it can be either continuously online or it can be a batch run. Batch run is a special run. Maybe you don't want that you need to synchronize it every time. You just keep on waiting, and maybe after 6 hours you need to synchronize. You run the replicate process after 6 hours. So there can be batch processes configured in your GoldenGate as well. We'll do that. We'll do it, and we'll let you know. But generally, it is online only. Generally, this is not used for batch processing. Batch processing, there are already many tools available. So GoldenGate is generally used for an online synchronization only. So wherever there is a real stream kind of stuff needed, then only we use GoldenGate. A real, what we say, replication of the data. Now there is commit sequence number, that is known as the change sequence number. Okay, this is CSN number, which is the commit sequence number. So this identifies the commit sequence, right? So once a commit is occur, it will increment this number. So this keep on incrementing because GoldenGate is working on the commits, right? So it picks the data as per first commit, will pick the data, the second commit pick the data. So it keeps on working on the commit. So it's keep this number is keep on incrementing. So this ends your module 2. Okay.